So with question 6, we look at amylase, which is an enzyme that digests starch in the digestive system. First thing it wants us to do is talk about why it has to be digested. So why does it have to be broken down? So simple answer to this one. So your starch molecules are quite complex, they're quite large. So they're large and they're also insoluble. So they cannot be absorbed into the bloodstream. So can't be absorbed into the bloodstream. Flipping on to the next one. Quite a lot of information here. So we use something called a colorimeter to investigate the rate of starch of digestion. This measures the percentage of light that passes through a liquid. So the darker or the more stuff you have inside a liquid, the less light will pass through, and you can use that as a measure of the concentration. So our student mixed 1 centimetres cubed of a starch suspension with some iodine. Then they measured the percentage of light passing through the mixture, repeated with different concentrations of that starch suspension, and you get these results. And you can see the higher the concentration of starch, the lower the percentage of light that passes through. So for example, if you have 40% of the light passing through, that means the concentration of starch must be 2 grams per decimetre cubed. If we have a look at this question, suggest what liquid was used for the test of the 0% starch concentration. Basically, we want any solution that doesn't have any starch in. So we could have iodine solution mixed with water, or just iodine solution or just water. As long as there's no starch in there, we should be fine. Explain the change in the percentage of light passing through the different concentrations of starch suspension in iodine. So the percentage of light passing through decreased as the concentration increased. And that kind of makes sense because the solution would have been darker in colour, and so that would have absorbed more light. So there are 3 marking points. So percentage of light passing through decreased as concentration increased. Solution was darker in colour, so that absorbed more light. On to the next one. We have brief method for an experiment. So they put 10 centimetres cubed of starch suspension into a test tube, add the amylase, which starts breaking down that starch into glucose, put them into a water bath for 10 minutes, mix them together, and put the beaker into the water bath, remove 1 centimetres cubed, add it to the colorimeter to calculate the percentage of light passing through, and then repeat it every minute for 5 minutes. So it asks us, why did we put the solutions in the water bath before being mixed together? This was to allow them to reach the optimum temperature. So allow them both to reach optimum temperature, which was probably 37 degrees, which is the temperature at which most enzymes work best. On the next page we've got a graph that I think we'll use for the following question. It just gives us the relationship between the percentage of light passing through and the time in minutes you are through this. So if we have a look at 6.5, It tells us that at 3 minutes the concentration was 0.3 grams per decimeter cubed, and it's asking us to calculate the mean rate of starch digestion in the first 3 minutes. And to do that, we'd need to work out how much we had at the start, subtract what we've got now, and then divide that by 3 to give us the rate in grams per decimeter cubed per minute. So it's quite a tricky one, and we're actually having to use data from figure 7 and figure 6, so we're going to have to go way back into this question and figure out exactly what information we need from both of these graphs. So I've got the final concentration. The next thing I think I need is the initial concentration. And so we could look up here and work out the final, but we've already got that, we don't have to do it. I want to know what it was at the start. So at time of 0 minutes, it was 10%. So only 10% of the light got through at the start of the experiment. Now I need to take that information all the way back to page 18, and I look at this graph, and I'm going to go across here where it's 10% until I hit that line, and I'm going to drop down, and if I read that off carefully, that should be 6.6 grams per decimeter cubed. So 6.6 grams per decimeter cubed. I can take that information back to the actual question I'm looking at. So the initial was 6.6, my final was 0.3, and that change took 3 minutes. So I use my calculator. 6.6 minus 0.3 divided by 3 should give me 2.1 grams per decimeter cubed per minute. So that's that rate of starch digestion. So how much it changed by divided by how long it took. Last question, last part of question 6, sorry. It happened at pH 7, so this was a neutral solution, and this would obviously be the optimum pH for this enzyme. Now if you change that pH too much, it's going to denature, it's going to change the active site of the enzyme. So let's say at pH 1, the active sites of the enzyme would change shape. That is denatured. This means the starch would not be digested. So that starch is not broken down by the enzyme because the enzyme has become denatured. So the percentage of light would not change. It'd stay at that initial value of 10%. So percentage of light passing through would remain at 10%. So 1 mark for talking about the active site changing shape, 1 mark for saying that the starch isn't going to get digested, and another mark for saying that that percentage of light passing through would not change.